All right, assalamu alaikum, everyone. Let's begin. So in our last session, we started normal distribution. We talked about some basics of this topic. So we started with this, that it's a continuous distribution. So it's used for continuous data. And then it's defined by mean and variance. You need to know about this notation. If you have something written like this, n, and then in brackets, you have a number and another number. The first number represents the mean and the second number represents the variance. But in your working, you're going to need standard deviation as well. So how can you find standard deviation? If you know that the variance is, for example, 25, standard deviation is just going to be square root of that. Okay. We discussed this in the last session. Then we talked about this normal distribution curve, that the area under the curve represents probability. Area under the curve represents probability. Now it's a symmetric curve with mean at the center, which divides the area into two equal halves. Since the total probability is 1, the total area under the graph is 1. So towards the right of the mean, you'll have 0.5, and towards the left of the mean as well, you would have 0.5. So we talked about this, and then we talked about probabilities. How do you find probabilities from normal distribution curve? We normally talk about probabilities for intervals here. All right. So we don't find probability of the variable being equal to something. We always find probabilities for intervals. We discussed the logic for that in the last session. But now, if you have to find the probability of an interval, what you're basically looking for is the area under the graph within that interval. Now, areas are usually found using integration, but we discussed that that's generally very tedious. So we use a table for that. So we talked about this table, that we will be using this table to find probabilities. But for that, you have to convert your data to a specific form, and that's called the standard normal form. Okay, so you have this letter z that represents standard normal. We said we would be using this formula, z equals x minus mu over sigma, to convert our data to the standard normal. And once you've converted the data to the standard normal form, we can use the table to find probabilities. All right, so that's what we discussed in the last session. So for instance, we talked about this particular example, that if we have a normal distribution in which we have a variable x that has a mean of 5.4 and standard deviation of 0.4, and we want to find a specific probability. So for example, what's the probability of this variable x being less than 6? How do we find that? The first thing we do is we convert x to z like this using this formula. So whatever value you have here, you find the corresponding value of z for that by inputting x in this formula. So we use this formula, put x equal to 6 here, mu equal to 5.4, and standard deviation equal to 0.4. That gives us probability of z less than 1.5. So once we have something in terms of z, we can use the table to find the probability after that. All right, so in the table, these values that you have in columns, sorry about that, the values that you have in the first column and in the first row, they represent values of z. We discussed how to read the table. So from that value of z, you find the corresponding probability. But remember, the table only gives you area to the left side of a value of z. So for instance, if you have a value of z here, the table is going to give you the area to the left of this value of z. So the area only, the table only gives you values of probabilities to the left of a value of z. And there's another condition, that is that the value of z that you have here should be positive. All right. So to be able to use the table, you need a form that looks like this. Probability of z less than a positive number. This is the form that is required to use the table. All right. So if you don't have this form, then you can't use the table. So if you have something else, you have to convert it to this form first of all. All right. So in this example that we were doing, we had this standard form already. We were looking for probability of z less than 1.5. So we were looking for the area to the left of z. and also the value of z here was positive. So it was already in the standard form, and we could use the table directly to find the probability. However, what if you do not have the standard form? What if you do not have the standard form? What do you do in that case? Let's talk about those cases today. So that's what we are going to do primarily. In this particular class, we will discuss what happens if you do not have the standard form already. How would you find probability in that case? All right. Now, let's think about these cases. So for instance, in this case, we started from this probability of x less than 6, right? What if we were looking for, so we had the same variable, let's say, x, and we knew that the mean of x was 5.4 and the standard deviation of x was 0.4. That's the information that we had. Now, let's say we want to find the probability that x is greater than 5.7. Now, how do you find this probability? How do you start? The first thing that you have to do is you have to convert it to z. Now, z equals x minus mu over sigma. Let's do that conversion. When we convert it to z, it becomes z greater than, you input 5.7 in place of x here, and that gives you 5.7 minus mu, which is 5.4, divided by sigma, which is 0.4. And what does this give you? This gives you probability of z greater than 0.75. This is what you get. Now remember, to be able to use the table, you need a form that looks like this: probability of z less than a positive number. So keep that in mind. This is the form that's required for the table. So you have to convert it to that form somehow. Now, how do we think about it? We think of the normal distribution curve. This is what the normal distribution curve looks like. Now, let me just paste that here. So this is what the curve looks like. Now, z is 0.75 here. So 0.75 might come somewhere here. Let's say this is 0.75. We have 0 in the middle, remember? Mean is 0 of the standard normal. 0.75 would be somewhere here. Now, what you want to find is the area to the right of this value. This is the area that you're looking for. All right, this is what we need to figure out. But remember, the table can only be used for area to the left of a positive value of z. Okay, area to the left of a positive value of z. You need something in this form, and you don't have that here. You don't have that form here. So how do we find this probability using the table? What we can say is, since the total area under the curve is 1, the total area under the curve is 1, we could say, let's find the area to the left of this point, to the left of 0.75. Now that's a form that we can find from the table. So if we find the area to the left of 0.75 and subtract that from 1, remember the total probability is 1. So the total area under the graph is 1. If we subtract from 1 the area to the left of 0.75, we would be left with this area. And now this is something that we can find from the table. So this is something that that is there in the table. All right. So what we do here is we say, let's convert this probability that we have here to a form that looks like this. All right. Now let me just take it to the side, in fact. So this is what you do. You convert this probability to something in this form. And now you can use the table to find this, z less than 0.75. Let's go to the table and see what we get from that. 0.75. You have 0.7 here, and you have 5 here. That gives you 0.7734. And that's the probability that you're looking for. 0.7734, and that's your result here. Okay, So if you're looking for this particular region to the right of a positive value, what you can do is you can just find that area by subtracting the area to the left of 0.75 from 1. All right, and that gives you the result. Let's move on. Let's say we have something else. We have a form that looks like this instead. So maybe we're looking for a probability of z greater than, so we have something in terms of x, let's say we convert that to z, and once we have converted that to z, we get something of this form, z greater than minus 1.45, let's say. So let's say we had something in terms of x, maybe probability of x greater than something, that converts to this value of z. Now, how do you find this from the table? Now, again, what you're going to do is you're going to start by thinking of the curve. This is how the curve looks like. All right. At the center, you have 0. So at the center here, you have 0. Where is minus 1.45 going to be? It's going to be to the left of 0, maybe somewhere here. This is minus 1.45. And now the area that you're looking for is to the right of this value, right? Greater than minus 1.45. 1.45 means you're looking for the area to the right here. This is the area that you're looking for. All right. Now, how do you find this area from the table? Again, this is not the standard form. Remember what the standard form looks like. The standard form is like this: z less than a positive number. You want something in this form. Now, this is not in that form. The sign is opposite. You have greater than here and also have a negative number. So it's not that standard form. Now, how do you find this area from the table? What we can do is we can use the symmetry of the curve here, which we do very often when you have a negative number in this place. What we do is we actually flip this curve. So this is what the original curve looks like, right? So this is the original data that we're looking for. Now, since we can't find this from the table, what we say is, let's find this area instead, that rather than looking for the area to the right of minus 1.45, let's say we have a value 1.45 here, positive 1.45. And what you do is you look for the area to the left of 1.45. That's this region. Now, this area is equal to the area that you have above. Since the curve is symmetric, the area to the right of minus 1.45 would be equal to the area that's towards the left of plus 1.45. So this original probability that we had here, we could actually convert it to probability of z less than plus 1.45. This is the same probability. And now this is something that we can actually find from the table because this is the standard form. So now this is z less than a positive number. Now we can use the table to find this probability directly. All right. Now 1.45, that's the value of z that we have. Just go to the table and look for where 1.45 is. This is 1.4, and you have 5 here, and that gives you 0.9265. Zero 0.9265, and that's what your probability is in this case. All right. So we had z greater than minus 1.45. We converted that to z less than 1.45, and that's the same area as well. All right, let's move on. Let's say we have something like this: probability of z less than minus 1.37. This is what we're looking for. So let's say we had something in terms of x, we converted that to z. That would give us, let's say that gave us something like this: probability of z less than minus 1.35, 1.37. How do you find this area from the table? Now, again, let's think of the normal distribution curve. This is how it looks like. Minus 1.37 maybe somewhere here. What we want is, we want the area to the left of this value. So we're looking for this region, right? Now, how do you find this area? Again, it's not the standard form. The standard form looks like this. It's z less than a positive number. That's what the standard form looks like, okay? This is not the standard form. You have the less than sign. However, you have a negative number here. So what do we do for this? Again, we do something similar to the last example. What we can start with is, we say, let's flip this curve. Let's flip this area. So let's take this to the other side first of all. Let's take it to the positive side. This was minus 1.37. We could take it here so that it becomes 1.37. And we can say that area in yellow is equal to this area that you have to the right here. It's equal to this area. So we could write this as, first of all, z greater than 1.37. All right. And now we can't even find this area directly from the table because, again, it's to the right of a value of z. We can only find the area to the left. So what we can do now is, we can say, let's subtract from 1 this whole region to the left of 1.37. So we could subtract from 1 all of this region, and that would leave us with this region to the right of 1.37. So that's what we do. We say, let's do 1 minus probability of z less than 1.37. And that is something that we can use the table for. Now we go to the table, find this probability, subtract that from 1, and that would give us the result. Now let's use the table to find this probability. Now this is the standard form, z less than a positive number. We can use the table for this. 1.37, that's the value of z that we're looking for here. 1.3, we have 7 here. And this gives you this value, 0.9147. We write that here, 0.9147, subtract this from 1, and that would give you the result. Let's see what this turns out to be. This is giving me 0.0853, and that's what this probability turns out to be. Okay, so that's how we deal with all of these different cases. So first of all, we started with something that was already in the standard form, z less than 1.5, that was already the standard form. We could use the table for that directly. If we had z greater than a positive value, like in this case, z greater than 0.75, we can subtract the area to the left from 1, and that would give us the result. So 1 minus probability of z less than 0.75 gives us the result. In this case, where we had area to the right of a negative value, what we did was, first of all, we flipped the graph. We said we could convert it to something in this form, and then you can use the table for that. All right, and in the last case that we have here, if we have z less than a negative value, we can flip that first and convert that to this area. Now, again, we can't find this directly from the table, so we say, let's subtract from 1 the area to the left of 1.37, and that would give you the result. You can use the table for that. All right, so this is what you do in other cases like this. Now, sometimes you can also have intervals. So you could have something like this. For instance, you might have to find the probability of z being between two values. So maybe z is between 0.34 and let's say 345 and 1.75. Let's say you have to find this probability. Now, this is area between two values. All right. So for example, we were looking at this case earlier. So maybe you were looking for the height being between two specific values. Sorry, where did that go? So maybe you were looking for something like this. Probability of height being between two values. So what if you have an interval like this? How do you find probabilities in such case? Let's think about it. Again, let's think of this using the curve. This is the normal distribution curve. Point 345 might be somewhere here. So this is 0.345. 1.75 might be somewhere here. Let's say this is 1.75. We are looking for the area between these two values. So we're looking for this region. This is the area that we want to find in this case. Now, how do you find this area? Remember, the table can only be used for area to the left of a positive value. Now, this is between two values. So how do we convert it to the standard form? What we can do is we can say, let's find the area to the left of 1.75. That will be all of this area to the left of 1.75. Okay. We can say, let's find the area to the left of 1.75. And then if you subtract from that, the area to the left of 0.345, that would leave you with just this area. That's the shaded part, and that's what you're looking for. So we subtract the area to the left of 0.345 from the area to the left of 1.75, and that leaves us with this area in the middle. Okay, so that's what we do here. We say this thing is the same thing as saying probability of z less than 1.75 minus probability of z less than 0.345. Now, both of these are in standard form. What's the standard form? Z less than a positive number. We can use the table to find these probabilities and then subtract them. So let's see what value you have at 1.75. 1.75 would give us 1.7 here and then 5 here. This is 0.9599. This is this first probability, 0.9599 from the table. And then the other one is 0.345. Let's figure that out. 0.3 and then 4. That gives us 0.6331. But then you have 5 as the third decimal place as well. That's here. You go all the way in this row. This gives you 19 here. So you add 9 to the end here, and that's going to give you 6350. So that's the probability that we have here. 0.6350. Just subtract the 2, and you'll get your result from this. 0.9599 minus 0.6350, and that gives me 0.3249. That's the probability that we were looking for. Okay, so that's this region in the middle. That's how you deal with a problem like this. Okay, let's take another example. Let's say we have something like this. Probability of z being between minus 1.75 and let's say minus 0.69. Let's say you're looking for this probability now. Now, again, you could think of the curve first of all. This is how the curve looks like. Where is minus 0.69? It might be somewhere here. This is minus 0.69. Then you have minus 1.75. That might be somewhere here. The region that you're looking for is this region between these two values. This is what you want to find. Now you see the values of z that you have here are negative. You don't have negative values of z on the table. The table can only be used if you have something in this form, z less than a positive number. Now, what do we do for this? We could do the same thing that we do for negative numbers usually. We could flip this. So we could take this area to the right. We could say this shaded region is the same as this region on the right side. If we had 0.69 here, 0.69, positive 0.69, and positive 1.75, this region would be the same as the yellow shaded region because of the symmetry of the curve. So the area that you have on the right side here is the same as the area that you have in the yellow shaded part here. So you could convert this probability to something like this. You could say that's the same thing as saying probability of z being between 0.69 and 1.75. This is the same probability. All right. And now it's exactly the same form that we did in the previous example. You have both positive numbers and you're looking for the area between them. What you can do for this is you can find the area to the left of 1.75 and subtract from that the area to the left of 0.69, and that would give you the area in the middle here. So you can say this is probability of z less than 1.75 minus probability of z less than 0.69. These are both the standard form. These are both in standard form now, z less than a positive number. You can find these probabilities directly from the table, and that would give you the result. Okay. 1.75, we already found in the previous example as well. That gave us 0.9599. We can write that here. 0.9599. What about 0.69? Let's go to the table and find this value. 0.69, so that's 0.6 here and 9 here. That would give us 0.7459. Let's write that here. 0.7459. Subtract the two and you get the result. 9599 minus 0.7459. That gives me 0.2140, and that's the probability that we were looking for in this case. All right. So that's what happens if we are looking for the probability of a case where you have two negative values and looking for the area between those two negative values. Okay. Let's take one last example that will cover all the possible cases then. Let's say you have something like this. You have probability of z being between a negative value and a positive value. So we considered what happens if z is between two positive values or if z is between two negative values. Now, what if z is between one negative value, so maybe minus 0.57 and 1.32. What is z between these two values? Now, again, we could start by thinking of the curve. This is how the curve looks like. And the area that we're looking for is the area between minus 0.57. So minus 0.57 might be somewhere here. Let's say this is minus 0.57. And then 1.32, that may be somewhere here. This is the region that we're looking for. Okay, the region between these two values. Now, how do you find this area? Now, for negative numbers, what we have been doing before is that we used to flip the curve, right? So that the negative goes to the positive side. But the problem here is if we do flip this, minus 0.57 will go to become plus 0.57. However, the problem is 1.32 will become negative in that case. So that's not going to be very helpful. All right. So in the previous case, when we flipped, both numbers became positive, and that was helpful. But in this case, if we flip, since there's one negative value and one positive value, yes, the negative will become positive, but then the positive one will become negative. So we still would have one negative and one positive number. So flipping right now is not going to help. So how do we think about this then? We can break it down. We can say, we could describe this area like this, the yellow shaded region. We could say it's the area to the left of 1.32 minus the area to the left of minus 0.57. Okay, let's break it down like that first of all, and then we'll see what to do after that. So we could break it down like this. First of all, we could say this area that we're looking for is the same as the area to the left of 1.32. So that's probability of z less than 1.32. And then subtract from that the probability of z being less than minus 0.57. All right, now this is something that we can find from the table. This is the standard form, z less than a positive number. We can go to the table and find this probability. Let's do that right now, 1.32. Let's see what value we get from that. 1.3 is here, and you have 2 here. The value of z that we get from this is 0.9066. Okay, so this is 0.9066. But how do you find this? This is not the standard form. However, we have done this example before. Z less than a negative number, we did that here. It's exactly this form. All right, so we use the same idea that we used here earlier. Z less than a negative number, we first flip it to take it to this side, and then we subtract the area to the left of this number from 1, and that would give us the result. Let's do that same trick here. We say, in order to find this area, we can do something like this. We can say minus 0.57 might be here. And what we're looking for is the region to the left of this. This is what we're looking for, right? This is the area that we're looking for. However, we can't find this directly. It's not the standard form. So first thing we could do is, we could say, let's flip this and make it this area. That will be the same, right? The area to the right of 0.57. Let's write that here. So we could write this as z greater than 0.57, because that's the same region as well. All right, so z less than minus 0.57 is the same as z greater than plus 0.57. But again, it's not the standard form. Remember, the standard form is z less than a positive number. That's the standard form. It's not the standard form yet. Now, since we can't find this area directly from the table as well, what we do is we say, let's subtract from 1 the area to the left of this. What's the area to the left of 0.57? It's z less than 0.57. Subtract this area from 1, and that would give you this probability. All right, so z greater than 0.57 is the same as 1 minus probability of z less than 0.57. So we subtract from 1 the area to the left of 0.57. So we basically subtract all of this region from 1, and that would give us the area to the right there. All right. Now, outside, we have 0.9066. This is something in standard form now. We can use the table and find this value. Let's see what this turns out to be. 0.57. So this is 0.5, this is 7. The value that you get here is 0.7157. Let's write that here, 0.7157. Now you just have to evaluate this, and that will give you the result. 0.9066 minus 1 plus 0.7157. Let's see what this gives us. 0.9066 minus 1 plus 0.7157, and that gives you 0.6223. That's the probability that we were looking for. Okay, so this is the most complicated case that you could get in this simple normal distribution, that you have to find the area between a negative value and a positive value. You'll break it down first like this, then do it step by step. Find this area separately using what we did earlier, and then just subtract and get the result. All right, so this is how normal distribution works. You'll have to find some probability that will be given to you in terms of x. First of all, the first thing you would have to do would be, you'll have to convert it to z. You'll have to convert it to z using this formula. Once you've converted it to z, you'll have to convert it to the standard form, which is z less than a positive number, this form, because this is the form that's given in the table. Once you've converted it to this form, you can use the table, find the probability, and you'll get the result. All right. Now, in the next class, we are going to discuss how to use inverse normal. Okay, so we're going to have an extra class tomorrow, by the way. We'll have a class tomorrow in the morning. Let me see what time it should be. Yeah, 10:15 a.m. tomorrow, or 10:10, in fact, 10:10 a.m. tomorrow. We will have another class in which we will be doing inverse normal. Okay. Now, before we end today, let's do one quick example in this to try and understand how this is going to be applied in an actual question. Let's do a question from the formula from the worksheet. The worksheet is uploaded in Classroom. The questions are assigned. Please make sure that you start doing those questions now. What we've done until now is one concept of normal distribution in which we have data given and we have to find some probability. This is one part of normal distribution. There are two other concepts after this. We will be doing the second one and the more difficult one of the three tomorrow, inshallah. All right, so we'll start that tomorrow. Now for today, let's quickly do one example before we end. Let me see if I can find one from here. Okay, let's do a simple one. This is question number 19 from the worksheet. Let's do the first part of this only. Second part is something that relates to inverse normal. We'll do that tomorrow, inshallah. Let's do this first part of question number 19, and then we end for today. All right, let's think about this. It says the daily minimum temperature in degrees Celsius in January in Ottawa is a random variable with distribution n minus 15.1 and 62. Remember what these numbers used to mean? If you have n minus 15.1, 62 written like this, n stands for normal distribution. So they're telling you that the temperatures follow normal distribution. The first number is going to represent the mean and the second number is going to represent variance. So it's a normal distribution with mu equal to minus 15.1 and variance equal to 62. What about the standard deviation then? The standard deviation would just be square root of this number, that's square root of 62. That's the standard deviation. Now, what are we looking for? We're looking for the probability that a randomly chosen day in January has a minimum temperature that is above 0 degrees Celsius. It says the daily minimum temperature follows normal distribution. Okay, so let's call this x. Let's say this is the variable, right? That follows normal distribution. What we're looking for is the probability that this temperature is above 0 degrees Celsius. So this is the probability that we're looking for, the probability of x being greater than 0. That's what you want to figure out. All right. Now, we have to first convert it to z. Remember, z equals x minus mu over sigma. We can't use the table unless we convert our variable to z first of all. So probability of x greater than 0 corresponds to probability of z greater than, you put the 0 here in place of x here, and you get the corresponding value of z for that. You'll get 0 minus mu, mu is minus 15.1, divided by sigma, sigma is square root of 62, and see what this gives you. You get z greater than something here. Let's figure this out. This would give you 1.9177. Now remember, in the table, the values of z are to 3 decimal places maximum, right? You can't have more than 3 decimal places. So before you use the table, you should round it off to 3 decimal places so that it becomes z greater than 1.918. Now remember what form we need for the table. You need the probability to be in this form. Probability of z less than a positive number. If it's not in this form, you have to convert it to this form first of all. Now, this is not the standard form. We have a positive value of z. However, we have greater than sign here. We want the less than sign for the table. Now, we could think of the curve. This is what the curve looks like. Now, what's z? Z is 1.918. That might be somewhere here, 1.918. The probability that you're looking for here is this, the area to the right of 1.918. But we can't find this from the table. The table only gives us area towards the left of a particular value. How do you find this? You can say it's the same as 1 minus the total area under the curve is 1. We subtract from 1 probability of z less than 1.918. So we find the area to the left of 1.918 and subtract that from 1. That would leave us with this yellow region. Okay, now this is the standard form. This is something that we can use the table for, 1.918. So the z value that we have is 1.918. Let's figure that out. 1.9, 1, and 8. Okay, this is what we're getting here, 0.9719. 0.9719. What do we have to add to it? Because we have a third decimal place there as well. Let's try to figure that out. You have 5 here, so you add 5 at the end here. That's going to give you 0.9724. The probability therefore turns out to be 0.9724 for this part. However, we have to subtract that from 1. So 1 minus this, let's see what that gives you. This should give you 0.0276, and that is our final answer, 0.0276. That's the probability of the minimum temperature being above 0 degrees Celsius on a randomly chosen day. All right. So that's how we use this normal distribution. Okay, so that's the first concept, that you have a normal distribution, but that sets the foundation for the next 2 concepts as well, because now we know how to use normal distribution. Now in the next class, we will learn how to do all of this in the reverse order. So for now, we were looking for a probability for a given data. In the next class, we would see, inshallah, how to find something missing from the data. So they might not, so maybe they don't give you the mean or the standard deviation, but they give you some probability. So we would see how to find the missing mean or standard deviation from the probability that they gave you. All right, so for that, we'll have to use the table in the opposite direction. So we'll have the probability given, we will find the z value from that, and then use the formula to find the missing values. But that's for tomorrow. We'll have a class tomorrow at 10:10. If you have any quick questions, you can let me know. Otherwise, that's it for today. I'll see you again tomorrow. Any quick questions? Anyone? No? All right. So there are no questions. I'll see you again tomorrow. Allah Hafiz.
Sir, I had a question.
Yes, Iman.
Sir, it's not about normal distribution, it's about discrete random variables. In their questions, in the first few parts, they asked about like something related to permutations or combinations. So if you get that
Yeah.
wrong and then you like use the same method for like making the probability distribution table, so do they give ECF for that?
It's actually very rare uh, to get ECF because. So can you give me a specific example from this? Do you have a
Yes,
question
sir.
number in mind? Yeah.
Uh, Sir, question number 7.
Okay. So what exactly is the question? So where do you think you should get the ECF in the last part?
Ye- Yeah, so like, because the first and second part, you have to do the probability that was like it's the combinations. And so if I get that wrong and if I use that method to make up to get to the probabilities for part 3, will there be ECF from that?
It really varies from question to question. It's not very predictable, to be honest. But uh, it's becoming rarer, unfortunately, in the syllabus that they give ECF. Uh, you don't find that very often. So if there is ECF, they always mention that in the marking scheme. In stats, they don't give it usually because even if you did get the first part wrong, you could get the other part correct without that as well. Because आप उसके बगैर भी दोबारा से कोई और मेथड भी आप यूज करते हैं तो आपके पास वो सेम रिजल्ट आ सकता था तो स्टार्ट्स में नॉर्मली जो है ना दे don't give it very often. Let me just check what they say for this question in the marking scheme. Question number 7. Yeah, so you see, you have A1, A1, A1. There are 3 answer marks here, all right? And they don't write follow through here. So if there was any ECF, they write FT here like this. So unfortunately, no, there is no ECF here.
Okay, sir. Also, sir, in question number 15, I don't get its last part.
Question number
15.
15.
So I get the probability. I just thought, okay, don't we have to multiply it by the probabilities that we found in the probability distribution table as well?
It's not really related to that. How do you think it's related?
Because sir, probability distribution mein it was X was basically the number of geese, right? So would it not depend if there is geese or not as well? Because there's a probability of there being no geese and there's a probability of it being there 1 or 2 geese. So like pehle wo honge and then we multiply it by whether the dog chases a geese or a duck.
No, but we're not choosing the geese here at all.
So we
Let me
just
actually
multiply.
let me actually read the question again. The farmer's dog is that chases other ducks. Okay, so we're not really talking about individual birds here. We are talking about them as a group. So whatever we did in the first part, that's kind of irrelevant.
Okay, yes, that makes sense. Thank you.
Yeah. Okay. So we're talking about them as a group, right? So that doesn't matter. We're not choosing any birds here. Okay.
Yes, sir. Thank you, sir. Allah Hafiz.
Okay. No problem. Allah Hafiz.